Hello students, today we will discuss the two important things, that is curl of a vector field and divergence of a vector field. First we will discuss the curl of a vector field. So what is this? So the curl of a vector field at any point measures the rate of rotation of that vector. That means it measures that how much the vector curl around the point in question. So suppose, for example, the existence of curl of V, the velocity at a point in a space, indicates circulation at that point of a liquid flow. The curl of a vector is also known as circulation or rotation. So suppose the curl of V is equal to 0, that means that if a wheel is placed in the liquid and it will not rotate, then curl of V, that means del cross V, is equal to 0. So del cross V is also known as curl of V or curl of A, del cross A. But if the del cross V is not equal to 0, that means the wheel which is placed in a liquid, it will rotate. Then the del cross V or curl V is not equal to 0. Another example is if a free magnetic pole is placed near a current carrying conductor, the pole rotates around the conductor. So that means the curl of H not equal to 0. But in case of electrostatic charge, the line integration E dot dl is always 0 and curl E del cross E is equal to 0. So what is the mathematical expression of curl A? That is I cap j cap k cap del del x del del y del del z a1 a2 a3. So it is similar as A cross B, where A is the curl or del operator and B is any other vector. Another important parameter, what is irrotational vector? That means if the curl of a vector field is 0, that means del cross A is equal to 0, then the A vector is called irrotational vector. That means it cannot rotate. And the example is gravitational field, electrostatic field, etc. Now what is the physical interpretation of curl of a vector? So suppose the curl of a vector, it has two direction. So one direction, that is the direction of the rotation of this a vector, that is the fingertips of other fingers, and because of this direction of rotation, the thumb direction is the direction of the curl. So the direction of curl, it obeys or it is defined by the right hand rule. The direction of thumb indicates the direction of curl, and direction of tips of other fingers are showing the direction of rotation. And this del cross A is equal to limit s tends to 0 cyclic integral A dot dl maximum by its unit surface dot n cap. That is, what is this? The curl of a vector at a point is defined the amount of maximum line integral at any point in a vector field per unit area enclosed by a curve, and it's directed along the normal to the plane of the area. Now the next topic is the relation between the angular velocity with respect to its linear velocity. So what is this? Suppose there is a rigid body R, it is rotating about an fixed axis. This is the fixed axis and through a origin O, and the angular velocity of this rigid body, that is omega, and the linear velocity v is equal to omega cross r. Now we have to prove that omega is equal to half del cross V or half curl V. So for this, first we would like to start from this relation, that is V is equal to omega cross R. So I cap, j cap, k cap, and omega component is omega 1, omega 2, omega 3, and the R vector, its component is x, y, and z. So this is the expression of curl, this is the expression of linear velocity V. Now again we will start the curl V, that means del cross V. So when we again do this del cross V, the answer is 2 omega, that means 2 into angular velocity. So omega is equal to half of curl V. So it is proved that the angular velocity of a uniformly rotating body is one half the curl of a linear velocity. Now we will discuss the divergence of a vector field. So what is divergence of a vector field? It is defined as the net outflow or flux of that field per unit volume, and it is defined by del dot A. That means del is a operator when it operates on a vector field, that is A vector. So del dot A is called divergence of a vector field. So del dot A is the measure of how much the vector A spreads out or diverges from a particular point. So positive divergence means del dot A, the answer will be a scalar quantity. It is when it is positive integer, then it is called positive divergence. Suppose there is a positive charge plus q, then all the lines of forces, electric lines of forces are spreading out or diverging from a particular point. So then the del dot A will be positive, and this point is called source. Now, what is negative divergence? So, divergence always operates on a vector field, and the answer will be a scalar quantity because it is a dot product of two vectors. Now, what is negative divergence? When the del dot A is the negative quantity, that means it is a negative integer. And what is its physical significance? Suppose there is a minus q here. So all the lines of forces are converging at a point. So then the del dot A will be a negative value, and this point is called sink. Now what is zero divergence? Zero divergence means when the answer is del dot A is equal to 0. So suppose the water is flowing in any container, and the inflow and the outflow is same. So if we place one box here, so here inflow and outflow is equal same, then the change in flask or change in flow, that will be 0. So that means divergence of this vector will be 0. Another example is magnet. So we all know that magnetic monopole doesn't exist. That means a bar magnet, it always has north pole and south pole. So magnetic lines of forces flow from north pole to south pole. So from now north pole it going out, and in south pole it enters. So all the lines of forces are closed. So if we place one volume or box here, so then the net inflow, incoming magnetic lines of forces and outcoming magnetic lines of forces are equal. So the change in flask will be 0. That means del dot B is always 0 because the magnetic lines of forces are always closed. That is why the V vector is called solenoidal vector, where del dot B is equal to always 0. Now there are another important concept, that del dot B is always 0 because magnetic monopole doesn't exist. So B vector is called solenoidal vector, magnetic field vector, whereas electric lines of forces, electric monopole exists. That means minus q plus q, they exist. So when there is a minus q only, then it can be negative divergence. And if there is only plus q, then the divergence will be positive divergence. But when we consider electric dipole, then if we consider this volume, then del dot E is equal to 0. But when the del dot E is value is positive, that means rho is a positive value, then del dot E is equal to rho by epsilon 0. That is why E vector is called non-solenoidal vector. That means depending on the case, it can be 0 or positive or negative. Now, thank you. Today I will end this lecture here.